Assalamualaikum and a very good afternoon. So today we will have EBP418 and I will briefly introduce to you experiment 5 which is plastic compounding by internal mixer. Alright, so usually there are 5 important process parameters to be considered in plastic compounding using internal mixer. Okay, the first one is the mixing time, the second one is the roto speed, the third one is the fill factor, the fourth one is filler loading, and the fifth is temperature. But in this experiment you will take into account the effect of filler loading using batch mixing. So this is the figure shows the internal mixer. So we have two of this equipment in our lab. So internal mixer. Okay. So it is basically used to mix material. Okay. For example, rubber or plastic. Okay. So the technique of internal mixer is batch technique. Okay, so it is not continuous, means that batch means that when you put all your material, okay, and also your additive, for example your filler, in the internal mixer in the chamber. Okay, so you let the reaction or let the mixing occur during certain time. Okay, after certain time you stop the mixer and then you take the polymer out. Okay, so that's the final product of your mixing. So it is a batch process, not a continuous process, because you put everything together, you stop, and then you get your polymer. Alright, so this figure shows you the mixing chamber. Okay, here, and it will have a 2 blade here to help to mix your polymer. So it will connect it to a drive unit, or we call it a torqueometer, where the torque and the stop temperature can be measured and recorded during the mixing process. So when you put everything, you set the temperature, so you can see the torque in real time. Okay, so you can record it or you can measure the graph. You can see the graph of the torque. So what is torque? So torque is the resistance to the material opposed to the rotating blade. So means that if the mixing is hard, so it need more energy to mix. So usually it will give you a higher torque. But if it's really easy to mix, okay, it give you ease of processing, the torque will be much lower if you compare to complicated mixing, right? Okay, so this is the internal mixer part. So consists of 9 components. Okay, the first one is a back section, center bowl, front plate, roto shaft, bushing, rotos, melt thermocouple, control thermocouple, and also ramp. So this is the mainly the main component for internal mixer. Right, so here's a video, so maybe we can take a look about what happened during the mixing in the internal mixer. This is the example of mixing inside the chamber. Okay, so you can see this is the blade. Okay, 2 blades, and you can see that polymer, the white one is your polymer melting, and the mixing is occur using the blade. Okay, so you can see that there's an orange material here. Okay, so they are putting something, an additive or a filler. So you can see later at the end of the processing, the material will turn into orange color, so indicate that the homogeneity of the mixing. Okay, now you can see most of the material already turned into orange color. Okay. Okay, so you can see here, this is the torque that they measure during the mixing. Okay. Right. Alright. Okay. So why all the filler loading is very important for us to observe. Okay, so as we know, addition of filler always help to improve the mechanical and thermal behavior of polymer. Okay, so relationship between filler and matrix actually depends on the filler loading. Okay, on top of that, it also depends on the types of filler, and the most importantly is the compatibility between filler and also matrix. So how do you want to observe the relationship between filler and matrix? Okay, one way is by using morphology. Okay, so through morphology you can observe the successful of mixings and how it affect the material performance. Alright, so for this experiment I will give you the results. Okay, and the objective of the experiment is to determine the factors that influence the effectiveness of plastic compounding process by internal mixer, and then you need to study the morphological properties of thermoplastic composite that you have produced. The material you are using in this experiment, so you have LDPE virgin, okay, without any addition of fillers. The second one is LDPE with 10% calcium carbonate. The third sample is LDPE with 20% calcium carbonate, and the fourth sample is LDPE with Bulkasil F. So there are many things you can discuss. The first one is without any filler. The second one is the difference between compositions of your filler, okay, of your calcium carbonate. And then the third is what happened or what you can see if you are using different fillers. Okay, so the equipment that you will use in this experiment is internal mixer and also SEM to measure the morphology. The temperature is 160 and different samples are added into your internal mixer where the top is recorded, so I will give the result later. And also to observe the morphology after you put your sample in internal mixer, then you immerse in liquid nitrogen. Okay, why? Because we want to freeze the sample, you want to see the morphology. Okay, if you didn't put in the liquid nitrogen, might be when you smash the sample to put into the SEM, it will have some deformation. So we don't want that. We want it to be solid. So that's why we put into the liquid nitrogen and smash the sample and put the sample in the SEM to observe the morphology. So there are two main observation that you need to observe. The first one is effect of fillers in top reading. Okay, you can see discuss the top reading. And the second one is the effect of filler in morphology. Okay, so this is the materials, okay, that you will use. Okay, you have 4 compound, and I will already give you the weight, okay, of the matrix and also the fillers. So this is the result for top reading. So you can see that different sample give you different top reading. So you need to discuss the effect of top, okay, if you are using different sample. And this is the result for SEM or the morphology. So there are different morphology without any addition of filler, with 10% calcium carbonate, 20% calcium carbonate, and also Vulcalcid. So you need to discuss the effect of all these parameters. So I give you a little bit of point what you can add in your introduction, and also result and discussion. So you just need to follow this point, and you can construct your result and discussion based on this 6 points. Right, and don't forget to put your reference. So I think that's all. Thank you.